Okay, guys, we are gonna go over how to add, multiply and divide and raise these trigonometric forms of the complex number, raise it to a power, and take a root of it. Okay? Basically, this is just good practice in how to deal with the sines and cosines of all our unit circle or our common angles on the unit circle, and how to use our calculator to help us with this as well. You do not have to memorize any of these formulas, okay? Here we have two complex numbers, and we want to multiply them together. Notice you just multiply the real numbers together, and then you take the cosine of the sum of the angles plus I times the sine of the sum of the angles. So if I was going to find the product of these two complex numbers, I would have 3 times 2 is 6. And then I'd have the cosine of whatever 45 and 135 are. I have to add those together, right? What's that? 180. Okay. That's what this is saying. Okay. You multiply the numbers together and you add the angles together. So I have 6 times, let's see, the cosine of 180 is -1 and the sine of 180 is 0. So I have 6 times -1, which is -6. If I was going to write that in rectangular form, of course, I'd have to write that as -6 plus 0i. All right, we don't have an imaginary part this time. Okay, so that is multiplying. Okay. Dividing is the same way as far as we just divide the real number parts, but we subtract. Okay, you end up subtracting the angles. All right. I don't think I have that on here. Okay, might be coming up. Okay, here is a very famous theorem in how to take a complex number and raise it to a power. Okay, you're gonna take the real number part and raise it to the power, just like you always have. Okay, but you're going to take the exponent and multiply it by theta. Okay, are you seeing some similarities in the properties of exponents? When we multiply, we add the angles, just like when we multiply, we add the exponents. Okay, for very similar reasons. Okay, same thing here. When I raise this to a power, I end up multiplying it times the angle. Okay, the only way we can do these, guys, is if we are in trigonometric form to start. Okay, I'm in rectangular form right here. Okay, I would have to take 1 plus I squared to 3 times 1 plus I squared to 3 times 1 plus I squared to 3 8 times. Not happening. Let's change it to trigonometric form. Okay, we have here that x is 1 and y is square root of 3, right? X plus yi. So r is going to be the square root of 1 squared plus square root of 3 squared, square root of 1 plus 3, square root of 4, which is 2. Okay, so this number is actually 2 times the cosine of what? Well, I know the tangent is y over x, so the tangent of theta is square root of 3 over 1. So that means that theta must be, I don't know if I'm in, let's just go with degrees. I was going to write pi over 3, but we'll write 60 degrees. Okay, so I have 2 times the cosine of 60 degrees plus I sine of 60 degrees, or I could write 2 cis 60 degrees if I want to write the shortcut. Okay, that is what I'm raising to the 8th. So now I know I take 2 to the 8th times the cosine of, what's 60 times 8? 480 plus I times the sine of 480. Well, 2 to the 8th, calculator, 2 to the 8th is 256. Cosine of 480. Gosh, how many times? I'm going to subtract 360 and see what I'm really taking the cosine of 120 plus I times the sine of 120. Okay, so I'm here in the second quadrant, 60 degrees up from 180. So I have 256. Cosine of 120 is negative a half. And the sine of 120 is positive square root of 3 over 2. So let's take 256 times negative a half. That gives me negative 128. 256 times square root of 3 over 2 gives me 128 square roots of 3. There we go. That was a lot quicker than multiplying that 8 times. Okay, this is your final answer. De Moivre's theorem. Okay, so that's how you raise a complex number to the nth power. Okay. Now to take the nth root of it. Okay, to take the nth root of it. Every non-zero complex number has exactly n distinct complex nth roots. So square roots have 2, cubed roots have 3, fourth roots have 4, okay, because they're complex. All right, every non-zero complex number has exactly n distinct complex nth roots. So here's how we find the nth root. We take the nth root of r, okay, let me move myself out of the way. We take the nth root of r, and then we take our theta and divide it by n. That's how we get this new alpha. Alpha is theta divided by n plus 360 divided by n, and you keep multiplying by k. K is 0, 1, 2, blah, 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 up to n minus 1. Okay? It's not as complicated as it looks. All right, that's how we take the nth root. So we're going to find all the fourth roots of negative 8 plus 8i square root of 3. Well, I need to write this in my trigonometric form. X is negative 8. Y is 8 square root of 3. So R is the square root of, let's see, x squared is 64. Y squared is 64 times 3, which is 192. So I have the square root of 256, which is 16. So R is 16. Let's see, the tangent of theta is y over x. So that's negative square root of 3. Okay. So let's see, tangent's negative over here, inverse tangent of that. So let's go with what? 120 degrees. Theta is 120 degrees. Okay, is that all right? That's where tangent of what? Okay, and I know I'm in the second quadrant. The reason I'm in the second quadrant is x is negative and y is positive. Okay, I'm in the second quadrant, and the tangent of theta is negative square root of 3. That only happens at 120 degrees. So now what I want to do is take the fourth root of negative 8 plus 8i squared root of 3. That's the same as taking the fourth root of 16 cis. I'm just going to do the shorthand, okay? 16 cis of 120. So that tells me I'm supposed to take the fourth root of 16, okay? And I'm going to take cosine of 120 over 4 plus 360 over 4n plus I times the sine of 120 over 4 plus 360 over 4n. Okay. Well, 4th root of 16 is 120 over 4. Is that 30 degrees? 360 over 4 is 90. Okay, and the same thing here. Sine of the 30 plus 90n. I'm supposed to do that up to n minus 1 times. So I have to do that for n equals 0, 1, 2, and 3. Okay, so when n 0, I just have cosine 30 plus I sine of 30. When n is 1, I have cosine of 30 plus 90. So that would be 120. Is that okay? Plus I sine of 120. And then we're going to add 90 more. So that's going to be cosine of 210. And I'm going to add 90 one more time. Cosine of 300 plus I sine of 300. Okay. Cosine of 30 is square root of 3 over 2. Sine of 30 is a half. Take my 2 through, and we have square root of 3 plus I. Yeah. Boomy. Now I have 120. So I have 2 times cosine of 120 is actually negative a half. Sine of 120, square root of 3 over 2. Whoops, I. So we end up with, distribute my 2 through, negative 1 plus I squared root of 3. There's my second one. Cosine of 210 degrees. Let's see, I'm in the third quadrant. So that's negative square root of 3 over 2. Plus I sine of 210. That's negative as well. Negative a half. Take my 2 through. I get negative square root of 3 minus I. And here, cosine of 300 degrees. Let's see, I'm in the fourth quadrant, so cosine's positive, so a half. Sine's negative, minus square root of 3 over 2i. Distribute my 2 through, you get 1 minus I square root of 3. Those are the 4 fourth roots of this. Okay, so this is a little review of all of, I know you have it there in your notes. If you'll just do these and bring those to class next time, okay? That's kind of reviewing 8.1, 8, this is 8.1, 8.2, these two, and then 8.3 and 8.4 kind of down here, okay? Try those and bring those to class next time, all right? Okay, see you then. Bye.